So last time, the last thing I did was a problem where a guy threw a baseball and we measured how far it went before it hit the ground. Here's the next problem. Anybody have any questions, I guess, before I start? Okay. So let's say that this guy here, sometimes I feel bad, like it's always men in my example problems, but I'm just like not good at drawing women. And also like it makes me embarrassed, like when I have to draw like certain parts of women's bodies, you know, like I feel like I'm being. Okay, so this guy's on a unicycle. Can't see his face. And he's holding a small ball. And he's moving this direction with a speed of 5 meters per second. This ball that he's holding is a distance, apparently he's very short on a very small unicycle, and this is 1 meter. And he is going to the idea is he's going to let go of that ball, try to choose the right time to let go of it, that it lands in a cup on the floor. Okay. So the question is, how far horizontally from the cup should he be so the ball lands in the cup? And let's say that the cup has a height of 15 centimeters, 0.15 meters. The first thing we have to do is specify those 4 values: time equals 0, time final, and then the coordinate system origin and the coordinate system orientation. So what do we want to choose for the time equals 0 instant? Right, when the ball's released. And what do we want to choose as our time final? Yeah, when it goes in the cup. There's a few ways to specify that, I suppose. I'm going to say when the ball reaches a height of 0.15 meters. Okay. And now for the coordinate system. These two are arbitrary, but I'm going to choose them the same way I pretty much always do. I'm going to choose the origin to be on the ground directly below where it's dropped. And I'm going to choose the y-axis to be up and the x-axis to be horizontal in the direction of motion. So the origin is on the ground beneath the release point, and the coordinate system orientation is the y-axis up, x in the direction of the motion. And now we're going to list out what we know and want. Do we know anything about the initial position? We know that the x component is 0. Do we know anything about the y component? 1 meter. Yep. So I'll just write that as 0, 1. Do we know anything about the final position? Yeah, right. We know the height. So we know PFY is 0.15 meters. The X final position is what we're looking for. Question? Because of where I chose the coordinate system. I chose the origin of the coordinate system to be directly underneath the ball. So it's just straight up the y-axis to where he lets go of the ball. Do we know anything about the initial velocity? Excuse me. Yes, we do. Yeah, right. So remember, when an object is dropped, at the instant it's dropped, the velocity is the same as whatever it's dropped from. So if we know the velocity vector of the unicycle, then we know the velocity vector of the ball at the instant it's released. So what's the next question is, what's the velocity vector of the unicycle? We know that the speed is 5 meters per second. So if we can figure out the angle, you know, the direction, then we can use that to figure out the vector. Since the unicycle is just going straight this way, you know, horizontal, not that way exactly. You can imagine putting the tail of the vector at the origin, and then you can see, you know, that it's in the direction of the x-axis, so that velocity vector is just going to be 5, 0. Okay. You could also maybe just eyeball it, you know, like recognize that he's moving totally in the x direction, so that vector is only going to be in the x direction. Any questions about that, translating that motion into, okay. So the initial velocity vector is 5, 0. Do we know anything about the final velocity? Nope. Do we know anything about the acceleration? That's right, in the y direction, and then in the x direction, it's always 0. So 0, negative 9.81. And then what about t final? Nope, don't know that. So are there any equations that have pfx in it and everything else is known? That's right, exactly. Nothing works here, so we're going to find an equation that lets us solve for TF. So no equation works. And equation 2y works to solve for TF. So PFY is equal to PIY plus VIY TF plus 1/2 AY TF squared. So that says 0.15 is equal to 1 plus VIY is 0, so this whole term is equal to 0. And then plus 1/2 times negative 9.81 times TF squared. That is negative 4.905. I just combined the 1/2 and the negative 9.81 TF squared. So subtract 1 from both sides and you get negative 0.85 is equal to negative 4.905 TF squared. And now divide both sides by negative 4.905. And I didn't do that step, but divide both sides by negative 4.905. And then you're going to take the square root of it. What? Did you calculate it? What is it? 0.416. Oh, you already calculated TF. Right. Okay. So if you solve this, you get TF is equal to 0.416 seconds. And now we know all of this information, and we also know TF. Is there an equation that'll let us solve for PFX now? Yes, there is. And that equation is just the x version of the equation we just used. So PFX is equal to PIX plus VIX, which is 5 times 0.416 plus, this is something, it's an easy mistake to make here, 1/2, what's the x component of the acceleration? 0. Don't accidentally put the negative 9.81 in there for the x component. So you get 0 and times 4.16 squared is still equal to 0. And so you get PFX is equal to, thanks, 2.081 meters. So try that. It works. Any questions about that? That's going pretty fast on a unicycle, though. That's like 12 miles an hour or something. That's the hardest part of this experiment. Okay. Yes.
The height of the cup when it touches the ball will go in there.
Mm-hmm.
But when we're looking at the y for the height, we're taking from the ground to the ball.
Mm-hmm.
Wouldn't it be like from the beginning of when the ball touched the cup to when he drops it?
This was supposed to go all the way to the bottom of the lake, to the ground. So these are both supposed to be measured from the same spot. Were you thinking like of this being the top of the cup?
Yeah.
Yeah, right. I just didn't draw it real straight. Any other questions? Okay. Since you're all so enthusiastic tonight, here's a problem for you. Warm-up problem. A ball is launched horizontally from 1 meter high. The speed is 20 meters per second. How long does it take the ball to hit the ground? Okay. Work on that for a little bit. Work together on it. Compare your answers as you go. And then I'll do it after.